Good evening everyone. Let's complete the chapter of amines today. Now we'll continue with the reaction part. The reaction with aryl sulfonyl fluoride, which is also known as Hinsberg reagent. Now this reaction C6H5SO2Cl reacts with amines of different degree and yields you a sulfonamide which is soluble in alkali in the case of primary amines. In the case of In this reaction, simply we tend to remove the HCl, one hydrogen from amine and the chlorine group of the Hinsberg reagent. Now when we do this reaction with a secondary amine, we form another sulfonamide, but since this does not have an additional hydrogen left, unlike the first one which had one additional hydrogen left to make it soluble in an alkali, this one does not have it. Therefore, this compound is insoluble in an alkali. Tertiary amines do not interact with benzene sulfonyl chloride simply because they do not possess a free hydrogen atom to react with the reagent in the first place for the removal of HCl. So it can be used as a distinguishing test for aliphatic amines of primary, secondary and tertiary nature. Now the electrophilic substitution reactions. Aniline is ortho-para-directing and electrophilic substitution direction has high density at ortho and para position. First of all, bromination. Now we have to remember here that aniline is an extremely activating group and without controlled conditions it can react extremely quickly. Therefore, in the presence of bromine water, it forms U246 tribromoaniline which has a light yellow PPT. If we want to do controlled bromination and get monosubstituted derivative, we need to deactivate the NH2 group. It can be done by adding an acetyl group using acetic using acetic anhydride in the presence of pyridine. This will substitute one of the hydrogens of aniline with CH3CO group, deactivating it, and then we can do bromination in the presence of acetic acid to get para-bromo as the major product, and then upon hydrolysis the acetic group is removed and you get the final major product. Similarly, for nitration, direct nitration is not possible because it is susceptible to oxidation. Therefore, amino group first of all again needs to be protected. We again do acetylation using acetic anhydride in the presence of pyridine, and then we use the usual conditions which we have used throughout the chapter of nitric acid and sulfuric acid at a given temperature, which gives you the product, and then further hydrolysis yields you this reagent. Now in strong acidic medium, aniline is protonated as anilinium ion NH4 positive, which is meta-directing, so it also gives a meta product in extremely decent quantity. As you can see, although 51% is still para major, but the second most major product here is 47% meta. So kindly consider this while doing the reactions of nitration in aniline in your examination. Now sulfonation, aniline gives sulfanilic acid, which is the major product, and it is a resonating structure. This H positive ion can leave from here and form NH3 positive here, and reverse can be done to form SO3H again. It is done using sulfuric acid at the given temperatures. Now aniline does not undergo Friedel-Crafts reactions like alkylation or acetylation because it forms salts with aluminium chloride, which is the Lewis acid, which is the catalyst we use during alkylation or acetylation to form the electrophile. This is due to the nitrogen atom on alanine acquiring a positive charge, and it behaves as a strong deactive grating group further in the reaction. Now benzene diazonium chlorides, extremely important part of your reaction, asked multiple times in the board examination. Aniline in the presence of NaNO2 and HCl, whose mixture gives you HNO2. Also, you can write it in the reaction part at 0 to 5 degrees Celsius, 273 to 278 Kelvin, gives you benzene diazonium chloride C6H5N2 positive Cl negative. This N2 positive and Cl negative part is ionic in nature, and therefore it can give multiple reactions which yields different types of products. The excess acid in diazotization reaction is necessary to maintain proper acidic medium and to prevent combination of diazonium salt with undiazotized amines. Diazonium salts are prepared and used in aqueous solution because in solid states they explode and cannot be maintained properly. Speaking of physical properties, they are colorless crystalline solids which are soluble in water and has tendency to explode whenever in a dry state. Now they are also stabilized by resonance, as you can see here. Now the carbyl amine reaction. It is similar to the Hinsberg reagent test, but this one is particularly for primary amines. In the presence of CHCl3 and aqueous KOH, it forms isocyanides, which is a foul smelling compound. Smells like a little bit of a rotten egg also. And methyl isocyanide was the gas which was released in the Bhopal gas tragedy, as you might have heard before. Now hydrolysis of isocyanides in the presence of water can yield primary amines as a reversible reaction. Reduction of cyanides in the presence of sodium and alcohol or as a metal catalyst can also give you secondary amines. Kindly remember, these are two distinct tests. One is the hydrolysis using water in acidic medium yields you primary amines, and if you have cyanides in the presence of sodium and alcohol, it yields you secondary amines. Some chemical properties of your nitro group include reduction using SN or HCl or catalytic hydrogenation of nitroalkanes. These are reduced to amines. RNO2 can be reduced to RNH2 using SN plus HCl. This can be used for aromatic routes also. If neutral reducing agents are present, then hydroxylamines are formed. Now the last part of this chapter, the reactions of diazonium salt, is up here. Diazonium salt, when reaction with H3PO2 in water, gives you benzene as a byproduct releasing nitrogen gas. By reaction with alcohol, it undergoes deamination and it also yields you benzene ring. In the presence of CuBr or HBr, you give bromobenzene. CuCl or HCl, you get chlorobenzene. Simple with copper and HCl also, chlorobenzene. With copper and HBr also, bromobenzene. All of them are methods for forming aromatic halides. With KCN or CuCN, you get C6H5CN, benzonitriles. With Ki, you get iodobenzene. With HbF4 in the presence of HCl, you undergo the Bald-Schiemann reaction and after heating you get fluorobenzene. This is the only method of you for creating fluorobenzene aromatic fluorides. Next, in the presence of water and sulfuric acid, boiling it would give you phenol. Reaction with phenol in the basic medium in cold temperature will give you para-hydroxyazobenzene. This is a coupling reaction. In this reaction, one of the hydrogen present at this particular para position of phenol gets removed along with the chlorine atom as a byproduct in HCl, and the nitrogen linking occurs between both the aromatic rings. Similarly happens with aniline also, and it forms para-aminoazobenzene, which is a yellow colored dye. Both of these collectively are known as azo-dye test or coupling reactions. This completes our chapter. Thank you very much for watching. We'll meet you soon with biomolecules.